This is the solution video for numbers 21, 22, 23, and 24. So most of these are just our exponent rules. Some of them look a little bit scary, but they actually simplify to be something nice. So if we look at number 21, we have division. In order to use our exponent rules, we have to have the same base. We do have the same base. So we can go ahead and subtract. So again, the base does not change. We take our numerator exponent, square root of 2 minus 2, and subtract our denominator exponent, square root of 2 minus 1. I use parentheses because if we subtract a binomial, we have to distribute that negative sign to both of those terms, not just the first term. So if I rewrite what I have, my first binomial does not change, but then my second binomial, positive square root of 2 becomes negative square root of 2, negative 1 becomes positive 1. So you have to be really careful with that if it's a binomial. If it's a monomial, you just subtract it, but a binomial, you're subtracting both terms, so sometimes the sign will change. So then square root of 2 and negative square root of 2 cancel out. So the scary part of the problem is gone. And then all we have to do left is do negative 2 plus 1. So we get 7 to the negative first power. Again, we can't have negative exponents in an answer. 7 to the negative first power does not make 7 negative. It puts it in the denominator and makes it a positive first power. And 7 to the first power is just 7. So our final answer, 1/7. For number 22, just looking at this, it looks weird. We can't simplify it. So whenever you look at a problem and you're like, what? There's a radical, change it to the rational exponent equivalent. So our base is 5, our index is 3, so that's our denominator, and our exponent is 6 pi. So just by looking at this, I can see I can reduce 6 pi over 3, and so 6 divided by 3 is 2, so I get 5 to the 2 pi. I would take this as a solution, but there's also another way we can write this. We can actually do 5 squared. So we can get 5 to the second power is 25, and then pi stays in the exponent. So I'm okay with either of these two. Number 23, we have an exponent to another exponent, so it's a power to a power rule. So we have negative root 3 times 2 over positive root 3. So this is just fraction multiplication. We can change negative root 3 to negative root 3 over 1. So when we multiply across the top, we get negative 2 root 3, and then across the bottom, positive root 3. So clearly, those square root of 3's cancel out. We end up with 6 to the negative second power. So again, just like in number 21, the negative second doesn't make it negative. It moves it to the denominator and gives it a positive 2 exponent instead of negative 2. And we know what 6 to the second power is. That's 36, so our solution, 1 over 36. Number 24, we can rewrite this in radical form. So the denominator of our rational exponent is 3, so that's our index number. Our base is 125, and then I always put the negative in the numerator as the exponent because we can't take a negative cube root. So the cube root of 125 can be simplified to 5, and we're left with 5 to the negative second power. Just like the problem before this, when we rewrite it, it's going to move to the denominator and become 5 to the positive second power, which gives us a solution of 1 over 25. That concludes the video for numbers 21 through 24.